Hi everyone, and welcome again in our second tutorial for creating the mesh. In the previous tutorial, we created 40 geometries for the idealized array. Here in this tutorial, we'll be creating the meshing for these 40 geometries, and we create the named selections or the boundary conditions labels that we will be assigning during our fluent setup, and then we'll be printing some stats and do some visualization to make sure we are making the correct setup on the correct meshing. So let's start. As you can see here, this is a notebook. Basically, this notebook is running over the CHPC, the cluster of the University of Utah. And the pipeline is very simple. We start by importing our CAD geometry and creating zones from labels, basically converting our just named selections into labels that we can use inside ANSYS Fluent. Then we will create surface mesh and the polyhedral volume mesh and print some stats and information about the mesh. And finally, writing the file. Normally, we are starting any Python script with our import. So we import a few libraries, some of them to read the paths and to record the time. Next, we are having some libraries that we'll be using to do visualization, namely PyVista. And if it fails for any reason, we are doing some try and except to make sure that it's still running. The two important imports here are related to ANSYS meshing prime. So these two lines are mainly the one will be used during the meshing. Next, a few settings or configuration related to the mesh itself. Start and end represent the numbers of the geometry or the number of first geometry and the last one. Minimum and maximum element size used inside the mesh. Prism layers is the number of inflation layers, as we will be doing some boundary layers, or as people used to do to work with ANSYS, they call it inflation layers, and the maximum sequence, and finally visualization. You can turn these flags into false if you don't want to do any visualization. Now, these three lines are related to the license connection itself. Unless you are using our University of Utah installation for ANSYS, you will need to change this path and you will need to point it towards your ANSYS installation or ANSYS license. Next two functions are related to the server connection. You can use them as this. And finally, this function is just to read the model and print it. Next function is to print some stats. So here we are getting a summary, namely the name of part, labels, which would be the inlet and outlet, number of nodes, and finally we are printing the maximum sequence inside the mesh. So we will be printing this after creating the mesh for each geometry. Our main function or our main mesh function is this one. So the model here, you can think of it as basically the pi prime or pi meshing one that will be creating the mesh itself. First step is to read the geometry, the CAD one. Then you are converting the zones into labels. Again, our name selections will be created into boundary conditions that can be used to assign boundary conditions inside ANSYS Fluent. Then creating our surface mesh using minimum and maximum element size assigned above. And then creating the volume mesh, the polyhedral one. You can see here we are making inflation layers or prism layers for all the boundaries except inlet and outlet, basically only the wall. And here is the number of prism layers. We used 5. And here we are showing our volume mesh and using the function of print stats, and finally writing the mesh. Here we have a very small for loop to loop over our all geometries, starting from 1 till 40. So let I can zoom out to have a better view, and let's do shift enter. It takes few seconds to start running and connecting to the server, and it should be reading the file, creating the mesh, and then visualize it after meshing. So as you can see, it start prime server is up. First geometry, the path to the geometry. This is just like a warning. You can just forget about it. This is the geometry before meshing, and then this is after meshing. You can see the polyhedral elements here, and this is our stats. So we have our labels, blood inlet and blood outlet, and number of nodes, and then poly cells. We don't have any tetral cells, which is good, and the maximum sequence as well, and so on. Each geometry takes around a few seconds, I can say. So, but it again, it depends on the geometry itself. Yeah. So that is the end of our meshing tutorial. We'll be attaching the script in the description as well, and see you in our last tutorial. Thank you.